In this video I'm going to show you a method called locating roots. It's a way of finding whether there's a solution between two particular values. It's where we can't usually solve equations. Now obviously the one I'm starting with, x cubed minus 3 equals 0, we could solve just by taking the 3 to the other side and finding the cube root of it. But I'm going to show you the technique using this example, and then you can apply it to a range of others. So we're going to start off with the equation x cubed minus 3, and we're going to call that f of x. Okay, and we want to know whether there's a solution between values of x of 1.4 and 1.5. So we're going to just simply put those values into the function. So we're going to have 1.4 cubed minus 3, which is minus 0.256, and then we're going to find f of 1.5. So that's 1.5 cubed minus 3. And that comes to 0.375. Okay, so just put those into our calculator. Right, just move that a little bit out of the way. So what's actually happening here, and what's the significance of it? So if you imagine the graph of x cubed minus 3, it's the x cubed graph shifted down the axis a bit, like this. And what we're trying to find out is whether there's the solution that is where this graph crosses the axis, is between 1.4 and 1.5. So we found the values of f of 1.4 and 1.5, and we've seen that one of them is a negative value, so that's below the axis. So we can imagine that 1.4 is here, and the other is a positive value, so we can imagine that 1.5 is here. Okay, so somewhere between 1.4 and 1.5, given that it's negative at 1.4 and positive at 1.5, the graph must have crossed the curve, and then therefore we can determine that there must be a root in that range. So in order to complete the method, we need to say there is a sign change, and so there must be a root in the range. So there, and actually we should also say, and the graph is continuous, because obviously there could be a situation where there was a positive and a negative value, but the graph didn't cross because there was an asymptote or a discontinuity in the graph. Right, so a sign change and the graph is continuous. And so we can conclude there is a root of x cubed minus 3 equals 0 in the range 1.4 to 1.5. And we can write that with square brackets like that. That can show us a range. Okay, next. In this example, we've got two functions, 2 to the x and x cubed, and we want to show that they cross in a particular region between x is 1.3 and 1.4. So let's start off with a quick sketch of those two functions. So we've got 2 to the x, which is something like that, crossing at 1, and then we've got x cubed, something like that. So we've got this point here where the two graphs cross, and we want to show that it's between x is 1.3 and 1.4. So what we're really solving is 2 to the x is x cubed, and I don't think we have the maths to solve that at the moment, so we're just going to use the technique of locating roots to show it's between those two values. So if we're trying to find where those two graphs cross, that's the same thing as saying 2 to the x minus x cubed equals 0, just taking the x cubed across. So if we call that function f of x, and then we input our values, so if we say f of 1.3, so 2 to the 1.3 minus 1.3 cubed, and that gives us 0.265. Then if we put our second value in, 1.4, so we've got 2 to the 1.4 minus 1.4 cubed, okay, that is minus 0.104. Okay, so obviously we've got a sign change between 1.3 and 1.4, and if we've got a sign change, that means we've got a solution to our f of x function, so therefore we've got a solution to 2 to the x equals x cubed. Okay, so again, we need to write our sentence. You get marks for the sentence and lose them if you don't write it. So sign change, and both graphs continuous. So 2 to the x equals x cubed has a root between 1.3 and 1.4. Okay. Next example, so this time our function is y equals x cos x. And we want to find if there's a turning point between the values x equals 6 and x equals 7. So if we want to know if there's a turning point, we need to find what dy by dx is. Okay, and obviously we need to use the product rule for this one. So we've got x times the differential of cos x, which is minus sine x. And then we've got cos x times the differential of x, which is just 1. Okay, so we've got there cos x minus x sine x. So we want to know if there's a turning point between the values x equals 6 and x equals 7. So let's call that, well, let's call it f dashed of x, and let's call this thing up here f of x. So f dashed of 6, you need to, oh, missed my x there. We need to use radians for this. The cosine of 6 minus 6 sine 6. Okay, so we've put those values into our calculator. We get 2.637 to 3 decimal places. F dashed of 7 is going to be the cosine of 7 minus 7 sine 7. Okay, and we get minus 3.845. Okay, so obviously here we've got a sign change again. So as we've got a sign change, we know that f dashed of x equals 0. There is a turning point to f of x between x equals 6 and x equals 7. Okay. There's quite a lot of turning points to that graph, actually. It's quite a nice little graph. It's, whoops, something like this, and then it sort of mimics that on the other side. So there's a lot of turning points, and one of them we found, I think it's probably, that'll be half pi, that'll be pi, 2 pi, I think it's that one there. Okay, but anyway, doesn't really matter, just threw that into for interest. Okay, all right, that'll do there.